Hi, and welcome to the ONF Spotlight on 5G. I'm Timon Sloane with the ONF, and today it's my pleasure to welcome Anil Bhandari, VP of Product Management at Altiostar. Altiostar is one of the leading disruptive Open RAN vendors, pursuing a strategy focused on the RAN, and in particular on software, the CU end of the spectrum of disaggregation, and on automation. Altiostar has also been publicly associated with Rakuten deployment, so I'm hoping we'll hear more about that today. Anil, I'm very pleased to have you here with us today, and I'm very much looking forward to your presentation. So with that, please take it away.
Thank you, Timon. Pleasure to be here. And thanks for the introductions. So I'm going to talk about Altiostar's open vRAN solution. Before I start my presentation, I would just like to emphasize on open and vRAN so that everybody is clear what I'm going to talk about. So when I say open, it refers to the disaggregation of the traditional RAN solution, which is generally provided as a bundle to the operators, and that's been the norm for many years in the industry. And then when we say vRAN, we are referring to the virtualization of the RAN software components. So that's what we refer to when we say open vRAN solution. And I'll talk about it more as we dive deeper into my presentation. Okay, so I'm going to start my presentation by first talking about the motivations, our motivations for developing an open vRAN solution. As you are aware that there was a discontinuity when the networks evolved from 2G to 3G. There was a transition from voice-centric to data-centric networks, and that led to the emergence of packet core technology in the wireless networks, which was capable of supporting very high throughputs. And now there is another transition happening in the wireless industry where with move from 4G to 5G, where obviously there is going to be now further higher demand for bandwidth. But other than that, there is an explosion in the number of use cases that a wireless network has to support, which means different applications have to be supported. There are use cases like eMBB, URLLC, massive IoT, and so on. And these have to be supported by the same network. So that's one thing. And then that is going to result in these different use cases are also resulting in now requirement to support thousands and hundreds of thousands of devices per site. So this means that the network has to be designed in a manner which it is able to support these very use cases, some of which are known today, and then unknown use cases of future without requiring a forklift. And operators should be able to support different services flexibly, again, without requiring much manual efforts. So this was one motivation. Moving forward, in this slide, I want to talk about the second problem which is there today in the industry, which is what I alluded at the beginning of my presentation, which is how the RAN is deployed today. So the traditional model today is what is shown in this slide, where you have baseband unit. It's a proprietary hardware which is typically running the different layers, RF layers, and then this baseband unit is connected to a remote radio unit. Again, this is also a proprietary hardware, and between these two, you have a proprietary interface. So bottom line is that operators have to buy this, you can say, a black box kind of solution in the market from their suppliers. And they don't have any flexibility in terms of choosing the hardware on which baseband software is running. Neither do they have a choice of selecting a radio vendor. Everything has to be purchased from one vendor, and that leads to all kinds of problems, which we'll talk about in the next slide. So it results in this kind of a deployment model where operators have to divide their deployments typically into 2 or 3 regions where they have radio access network supplied by one vendor. And this creates a lock-in situation. Now, if operator wants to change the hardware, radio hardware for some reason, they cannot do that. Obviously, with this, it limits the innovation. Further, what happens is that now, from the same vendor itself, if they are supplying small cells and macros, many times you would find that the software is different. So small cell software will be different, macro software will be different, and even sometimes between 4G and 5G, there will be difference in the software. So that results in management complexity, basically. And then finally, all this also because there is now tight coupling between the hardware and software, so that leads to a slower rollout of any new services. So this is the current model and the constraints. And again, this was one of the motivations. We thought, how are we going to change this, right? And make things simpler. So this slide shows the open vRAN architecture, what Altiostar has implemented, where what we have done is, first thing that we did is we have decomposed the baseband into CU and DU. So CU is hosting non-real time and DU hosts real-time functions. And then what we have done is that between CU, DU and the RHs, we implemented open interfaces, standardized interfaces. So for example, between the DU and radios, we have implemented ORAN 7-2x split. And between CU and DU, we have implemented F1, which is defined by 3GPP. And I have another slide which talks about that. So this results now in yeah, one more aspect, that the DU and CU, they are now implemented as containers. These are all CNFs, and these are now running on COTS hardware. So now if you see with this disaggregation, first benefit is obvious, that operators can now procure hardware independently. So they can procure the hardware for CU and DU independently. They can buy radios, best of the breed radios, independently from the market. And all this can be put together, and I'll talk about what we do to make sure that all this works together. So this is now bringing a lot of flexibility to the operator, first of all, in terms of how they want to architect their network, and they can go for bespoke hardware, or their whatever features they want. Secondly, what also happens is that because now DU is virtualized, it can run in edge cloud, which is what we have done in Rakuten. And as a result of that, site is simplified. Now at the cell side, operators potentially will have only radios, and all the other complex equipment is residing in the edge cloud. So that further helps not only in the CapEx, but also OpEx, and we'll talk about that. Further, another thing that we have done is that our software is common, which means that the same software is used for the small cells, for macros, for massive MIMO. And that, again, that way, what we can say is it's like a converged RAN software, and that basically brings down the operational complexities and helps in troubleshooting. So if a UE is moving, for example, from a small cell to macro, you will get the traces, which is a common set of traces generated from the CU. And eventually it results in high services velocity because software is disaggregated now from the hardware. So any new features that are required, those are developed in the software without any dependency on the underlying hardware, right? If a feature requires more compute cycles, fine. You have to increase the number of computes, but still, I mean, that doesn't prevent you from developing the new feature, versus in the traditional model where you have to do the forklift of the entire baseband unit in many cases. So what it leads to, I mean, in terms of business model, whatever we have done, that this shows how now in open vRAN, the role of, let's say in this case, Altiostar, where we provide the software, which is what is indicated in the middle, and then off-the-shelf hardware, for data centers is coming from the operators. Third-party radios, again, operators procure themselves. What we do is we play the role of ensuring that we certify this hardware end to end. So the entire solution is certified, and we make sure that the KPIs are being met. So operators still get a certified solution. It's just that they do the procurement of the hardware themselves. So that's what happens. And then integration, again, Altiostar can play a role, or what we are doing is that we are working with multiple services partners now. So there are many large companies who are involved in the process. And then operators can go to these companies, and then they will help do the integration. This slide just expands on the point that I made in the earlier slide about the role that we play. So with disaggregation, Timon, there are concerns that have been raised by some of the companies about that this is going to make things more complicated for the operator. And what we are saying is that that's not really correct. And this is based on our practical experience, where we play that role of that glue that unifies this whole disaggregation. So what we do is that we go above and beyond normal RAN vendor would do, where we work closely with the operators right from the requirement finalization stage. So we work with them to finalize the requirements, do the feature design, finalize their management architecture, and then during the solution development and validation process. And even beyond that, what we do, and there's something unique, is that we also work with operators to identify if there are any hardware gaps. And if there are hardware gaps, then what we do is that we get the reference designs done. So we do the reference design, and then we provide that reference design to the operators, so that then they are able to get it manufactured. So that way, what I'm saying is that we make sure that anything that operator requires to make the network whole, that is addressed by us, be it software or even in terms of any hardware gaps. And then the deployment is obviously done by the integrator. So that's the model. So overall, this is now the transformed network. I'm saying that we are, with Open vRAN, now you have standard interfaces, and what role we play in this is where we are, we supply our CU/DU software along with APIs for automation. And this is, the entire thing is certified by us, by Altiostar. Little bit about how the architecture looks like. So this is, so we have, what we have done is that we have disaggregated our G-Node B into CU/CP. So we have implemented CUPS architecture. So we have CU disaggregated into CU/CP and CU/UP. And these are running, as I said, these are all running as containers, cloud native functions. And then DU is also containerized. And these are all standard interfaces. So we have F1C interface, F1U interface from DU to CU/UP, and then NG2, NG3 interface towards 5GC. And then from DU to radio, we have ORAN 7-2X interface. And with this architecture, we are supporting macros, as I said, small cells, and even massive MIMO deployments. This is a view of the end-to-end network architecture, where typically we are showing, and this is actually the way we have been deployed. So CUs are typically deployed at central locations at the central data center, along with EPC, IMS, and other core equipment. And then DUs are deployed in the edge cloud. And then we have open interface with the radios. And then on top of this is very important layer, which is for, which contains the services orchestrator, VNFM, and the OSS. And this is the layer, we very closely work with these vendors, to ensure that using this layer, we implement, completely zero touch operations. That includes not only the commissioning process, but also use cases like self-healing. And that has really helped in reducing the number of, people who are managing the network. So it is helping in web scale operations. This slide shows the power of zero touch commissioning. So here, this is actually working in the network. So Altiostar sites are commissioned in less than 10 minutes today. If you compare it to the earlier scenario where operators would have to outsource these services, and vendors will then develop scripts and so on, and the process used to take weeks versus minutes here. So what are the different deployment models? So it's not that vRAN only supports edge cloud model. It's a very flexible solution, as I said. So we support edge cloud model, obviously, where DUs can be deployed in edge cloud. However, if operators have sites where they don't have optical transport available, they have maybe microwave. In that case, the CU still will be hosted in the central data center, and DU is deployed at the tower location. And then these DU and CU are interconnected over higher layer split, so over F1 interface. And then we also have full DRAN model where CU and DU both are hosted at the cell site. So this slide kind of summarizes the choice that is there in front of operators. So one is to continue with the traditional model, which is on the left. And what happens here is that you have a refresh cycle, which is triggered by either new technology or new features. And these refreshes result in a hardware refresh, which means the baseband units and radios are changed every now and then. So maybe, after few years, there is a cycle for hardware change, which causes network disruption, services disruption, and obviously other CapEx, OpEx impacts. Now, if you compare that to this architecture, this is more a periodic cycle of what I call as software innovation, where every time there is a new technology or new feature, because you have now softwareized everything, you do innovation in software. Underlying hardware, yes, you may have to add more compute, but the innovation is happening in the software. In this slide, I talk about what is going on in Rakuten. So Rakuten, this slide shows really Open vRAN in action in Rakuten. Today this is the number of sites as of June. So, greater than 5,000 sites are on air. Each site is having a minimum of 3 sectors. These are all 44R macro radios, high power radios. And these sites are serving some of the densest cities in the world, in Japan. So my point is that the deployment is in dense urban areas. And it's working very well. This is all public information that I'm sharing. The data volume per day today, whatever subscribers are experiencing, that is twice the other, twice of the other Japanese operators. The RCS calls are 2 to 5x more than the VoLTE calls, and there is high video demand. Also, the stability is very good. It's 99.7% availability, accessibility, and retainability. All these KPIs are very good KPIs. And OpenSignal, they carried out their own analysis, and they have published a report, and they have also accepted that the performance meets or beats customer experience KPIs globally. So my point is that what it shows is that Open vRAN is ready for prime time and demonstrating very good performance. This is my last slide. So just want to talk about that. Ultimately, our idea is that the 5G technology should be for masses. And we believe that Open vRAN will help accelerate that process through various focus areas that we have shown here in terms of open architecture, virtualization, automation, and so on. So this is where I would like to stop. Thank you very much.
Neil, thank you, and thank you for sharing today. And I really appreciate you coming, and really appreciate your presentation. So, if you don't mind, a couple of questions occur to me as you're going through, and I guess maybe the first place I'm thinking about is some of the equipment. You're describing your strategy as being sort of a virtual CU, a virtual DU, running on COTS hardware.
Mhm.
What do you view as the need for accelerators? Anything special in a DU or are you really just running on DBDK or what's your strategy there?
So, Timon, we do require on DU accelerators are required. Today we are using FPGAs, and in near future these will be replaced with ESX. So yes, accelerators are definitely required for FEC offload.
Okay, good. That's helpful. And on your provisioning slide and the zero touch slide, I'm curious how zero touch it can be. I mean, does the operator, so you drop in a new RU, but then the mapping from RU to DU, DU to CU, is that pre-configured? And so, the system's kind of waiting for that device to appear?
Correct. So what is done is, Timon, obviously system needs to know, right, what is the mapping. So pre-provisioning is done. So that pre-provisioning basically indicates that a particular RU serial number is mapped to which side. And then what happens, so this mapping is done on the OSS. And then once the radio, so only that mapping is required to be done. And then obviously some site specific parameters have to be pre-provisioned, right? Rest are all golden parameters. And once that is done, then the installers, they install the equipment at site and then they power it on. And once they power it on, after that the entire process flow is automatic. So once they power on, the ID of that particular radio, so once they power on, then after that, the first thing that happens is that the EMS IP address is resolved, and then the RU is able to reach to the right EMS, and post that EMS then communicates to the OSS. OSS now notifies the orchestrator, and then orchestrator now has the information to check whether that VCU on which this particular RU is to be hosted, whether that VCU exists or not. If that VCU is not already there, then that VCU is instantiated, the VDU is instantiated, and then after that, the associations are created. So it's basically after power on, there is no other intervention required.
And the devices are vanilla, just stock devices that are, you just have to get the right serial number in the right location.
Absolutely.
Nothing else.
That's all. That's all. There is nothing else required.
Yeah. Okay. Good. Thank you. Thank you for that clarification.
So unlike, if I may add, if you remember in earlier days, and I have worked on the systems where custom scripts were created, and these custom scripts required actually tools, specialized tools to generate those scripts, and those scripts had to be loaded, etc. No such thing is required. Even during pre-provisioning process, no such thing needs to be done.
Yeah, and I can imagine that the amount of time needed on site, the skills needed on site are vastly different. Right?
And mistakes, right? The mistakes that used to happen in writing these scripts and all that. So all that is now that's not the case.
Right, and then you're virtually assured that your inventory system is matching your real network because you essentially define the inventory system before you deploy, and right, so makes good sense. So let's see. In the Rakuten deployment, I believe it's public that you're working with Nokia radios, and then maybe Sercom is in that mix too. Is that right? And Altiostar played a role of helping to integrate. Is that how it kind of came together?
So yes, we are working with a large traditional vendor. I may not be able to take the name, but yes, we are working there with a traditional RAN vendor who has supplied the radios in Rakuten network. And then yes, with Sercom, definitely, yes, I can talk about Sercom. So Sercom is providing these small cells, and all the macro radios have come from this vendor, and those radios are working with our baseband, our vRAN software.
I see. So traditional vendor for macro cells and Sercom for small cells. Is that how
Yes,
that worked out?
absolutely.
Yeah. Okay.
Yes.
Good. Thank you. And let's see. I think there was also an announcement with Mavenir, maybe more U.S. focused, about working with radios. Do I have that, or trying to foster availability of a greater selection of RUs? Is that?
Absolutely. I mean, so Timon, what we are trying to do is we are trying to make sure that open vRAN system, overall ecosystem grows, right? And as I said, wherever we are finding gaps in the ecosystem, we are trying to make sure that those gaps are addressed. So this is one of the gap that we identified, and we decided to join hands with Mavenir to address, some of the supply chain gaps. So that's where we are collaborating and making sure that those gaps are addressed.
So it's really, the gap is a broad selection of RUs with different bands supported, and for different, macro, micro.
Yeah, especially in US, we saw that gap. So we have joined hands, and wherever we see it, maybe we'll collaborate further.
Okay, good, thank you. So, and then I'm curious on your view of the RIC and XApps. So in your presentation and part of the ORAN architecture, there's been this horizontal disaggregation, RU, CU, and that seems to be getting to be pretty well known. And now there's starting to be more of a vertical disaggregation that's been part of the architecture, but is maybe getting discussed more. What's Altiostar's view on that sort of next step in disaggregation?
Absolutely. So thanks for asking this question. And we are very much aligned to this, and we see this as the next stage of evolution or disaggregation. So Altiostar, and we believe that in a way, right, this disaggregation again is going to bring more innovation, because with the RIC, what is now going to happen is that there is going to be an opportunity for, again, innovative companies to come bring their own algorithms as XApps, and that is again going to further improve the efficiency of the network. Secondly, we also believe that with this architecture, operators will be able to now implement their bespoke algorithms. So that way, operators can now differentiate themselves from the other operator, which, today, if you see, the only opportunity for differentiation really in the traditional RAN arena, only opportunity for differentiation is maybe by having, let's say, better optimized network, right, compared to your competitor. But otherwise, the opportunities are limited. But once you have this kind of architecture, now you have, opportunity for additional innovation, and, making sure that, you have algorithms which are tailored to your needs, right?
Right. No, that makes a lot of sense. Yeah. Okay, good. Yeah. So thank you for that. And then I'm curious, maybe to switch gears a touch and talk about business models. So you got into it, and if I got it, the takeaways correctly, you described Altiostar as really playing and being happy to play an integrator role. And you even made a clear statement about operators should procure their own hardware. You might even help them fill some gaps in their hardware. So I thought that was a really nice, clear statement. It seems like you have a nice, clear strategy. And clearly, integration is one of the bigger challenges. You disaggregate, then you have to bring it all back together again. So and, we've seen that in other
verticals
clearly where we've done sort of disaggregation. And now we're facing that in the RAN space.
One One clarification, Timon, I'm sorry. So what our business model is, just to clarify, we we supply we are a supplier of vRAN software. That's where we
Mhm.
play. And what I mentioned is that we recognize that operators still need confidence that end-to-end solution will work. So therefore, what we do is that we work closely with the selected vendors, and then we do end-to-end certification. So we collaborate, we make sure
Mhm.
that end-to-end solution is certified, that it will meet KPIs. So
Mhm.
baseband hardware, COTS hardware, our software and radio, and let's say whatever packet core has been selected. So that's one thing we do.
Right.
Secondly, what we are doing is that on the northbound side, we work closely with the selected orchestration vendor, OSS vendor, and we make sure that the automation framework is in place, because that has significant bearing on the OpEx for the operators. So we work there. And then thirdly, what we are doing is that we identify if there are any gaps, let's say on the hardware side, and there we help by doing some reference designs as need arises. So these are the three areas.
Mhm.
But as far as the actual, site deployment and integration, commissioning, traditional services activities concerned, we don't play there. However, we do have partners, some large system integrators. We work with them, and they are the ones who carry out those installation commissioning activities. So the traditional SI role is something that we don't play today.
Yeah. Got it. And by traditional, it's more the physical installation and
That's
the thing on the towers and all of that.
that.
Okay, that makes perfect sense. And those really are different sets of skills. Being able to do that physical installation versus the logical um, installation and certification, or solution crafting and certification.
That's
So so that's interesting. So that when we think about it too, with this emergence of XApps and kind of as a vehicle for innovation, suddenly some software components are going to get mixed in as well. So you've got, you said you're happy to embrace bringing in different hardware components, and you put your software on it and do the certification. What about what's your vision for when a market for XApps starts to emerge? How do you think that will change things?
I mean, as I said, that as XApps emerge, one of the obviously key roles that we see is that we should continue to support open interfaces, and that will mean that we will support open interfaces with, let's say, near real-time rig, right? So if operators are bringing near real-time rig from another provider, we'll ensure that we are supporting open interfaces there. And if
Hmm.
we have our own near real-time rig framework, then also we'll make sure that we are exposing the APIs, which are, which can be used by the other applications. So today, as you know, I mean, those APIs are not very well defined. But
Hmm.
again, the whole idea would be that, other vendors should be able to participate and do innovation.
Hmm. Right. And
That's
again,
the win-win strategy in my view.
right. Yeah, I think this is kind of maybe the next big hurdle in Open RAN that the industry is facing. And because what that logically leads to is needing vendor A, B, C X apps kind of all running on top of a RIC and integrating that, and that's going to be yet another level of integration, right? Not just northbound, southbound, but it's sort of side by side those different X apps and how they share resources and all of
Absolutely.
that, resource contention. Um, but it sounds like you're bullish on that vision and view, and you
Absolutely.
see that, and
Absolutely.
you still have
Yes.
a role to play there. And then maybe the last question on the business model is around licensing. I mean, historically, when software is attached to hardware, it gets licensed as a sort of bundle. And when you move to this virtualized world, disaggregated world, licensing, a lot of new options are available. And I'm wondering if maybe you have any. I don't know if you have a strategy you could share, or lessons learned, or anything unique about licensing that has come up as this market has shifted.
I think again, I will connect, I will just reiterate our vision. And our vision, as I said, is to simplify everything, right? So simplified architecture and similarly, from that vision, I would say we have also, we are following that vision for our software licensing model also. So we have a highly simplified software licensing model without any, so we don't have complicated optional features and all that. Generally, so we have a standard software license, and that's what operator gets, and they don't have to worry about what all new features or what are the optional features that they have to buy in future.
Okay, well, good. Well, Anil, thank you very much. I really appreciate you being here with us today and sharing what's going on with Altiostar and putting up with my questions as well. So thank you very much.
Thank you, Timon. I appreciate it.